In this video, I'm going to take a look at additional problems where I apply the modern square of opposition from Chapter 4, Section 3. I've already gone through a video where I explained the basics of this in considerable detail, even tying in concepts from all the way back to Chapter number 1. So at this point, I'm going to assume that you've watched the first introductory video, really, on applying the modern square. You've got the basic setup down, but maybe you're struggling with some of the more complicated examples. So at the top of the sheet, I know the type here is kind of small, but at the top I just have a set of cliff notes, if you will, including concepts from earlier, even in Chapter 4, identifying the letter name of a proposition. That's crucial for applying the modern square. So I have listed here the form of A, E, I, O propositions. Just so that we can refer to that. You might want to have your own sheet of notes or your text open as you're going through this particular exercise. And here just below that, I've continued my notes by sketching out the modern square. And obviously you'll want to have the modern square in front of you, either your own version in your notes or just simply open to the appropriate page in the text. So this might be kind of a mess to look at here, my own chicken scratches, but it's got the basic modern square from 4.3 down. So those are just notes. Let's get to the actual examples here. If you can't read this, follow right along in Chapter 4, Section 3, and I'll read through this, of course. So we're testing an immediate inference. There's just one premise followed by the conclusion. And as we discussed in the previous video, what we want to know is whether or not the immediate inference is valid or invalid. So in our first example, the premise, it's false that some lunar craters are volcanic formations. Therefore, our conclusion, obviously, no lunar craters are volcanic formations. So we're going to begin here by identifying the letter name of both the premise and the conclusion. We're going to strip away all the content. So premise 1, I know it starts with it's false that, but I'm going to ignore that. We have some SRP. The structure, I'm going to look back up to my notes, some SRP. The premise is an I proposition, therefore no SRP. The conclusion, no SRP, that's an E proposition. So I'm going to plug this then into the modern square. But notice, unlike the example that we took a look at in the other video, the premise here is negated. It is false that. So that tells us that our I proposition is false. But in testing an immediate inference, we want to assume that the premise is true. So the premise itself is true, though the I proposition, and that's the form of premise 1, right? Some SRP. The I proposition itself, we're told, is false. And then the conclusion, again, is an E. So let's look at the relationship between I and E, our premise and our conclusion. According to the modern square, we're moving from I to E. And the relationship, if you can read my chicken scratches, if not, take a look at the printed copy in the text, obviously. But the relationship between I to E is contradictory, meaning that they must have opposite truth values. So if our I proposition is false, though we assume that the premise itself is true, if I is false, E must have the opposite value. So I is true. Our premise, we assume, is true. E, now we figured out, according to our modern square, is true. So true premise followed by a true conclusion, that would be valid. Remember, for invalid, we want all true premises, and for an immediate inference, there's only going to be one premise. So for this exercise, a true premise followed by a false conclusion. If we have that, it's invalid. If we don't, it's valid. Here, we don't have that example, so it is, in fact, valid. And if I've lost you, that's the nice thing about a video, right? There are some advantages to taking online classes. You can pause. You can go back and watch it again and again. But it might help to just put that on the back burner for now. Go back and re-watch if you need to. But let's just move right along to our second example. There are many other examples in the text, and of course, you're provided the answer key. Of course, it's possible to make a series of mistakes and still get the right answer, but that's a pretty good indication that you're on the right track. You're not on the right track. If you're not on the right track, by all means, contact me. Come to my office, send me an email, and we can have a back and forth exchange, a one-on-one session. So all trial lawyers are people with stressful jobs, and we don't care about the content. Let's look at the structure. Let's identify the letter name. All SRP. All SRP, our premise is an A. The conclusion, therefore, some trial lawyers are people with stressful jobs. And we don't care about the content, some SRP. Some SRP, this is why I have my notes up here, some SRP, that's an I. So we have an A to I inference. And let's check out the modern square. A to I, we're told, and I've just abbreviated here, logically undetermined. There isn't a logical relationship between the two. So we assume always in testing for validity that our premise is true. So I'll just put a T here for my A. What's the relationship between A and I? It's logically undetermined. There's no logical connection. So we saw this in an earlier video. Our I, it could be true or false. It's true or false. It does have a truth value. We just don't know which is which. We've got an epistemic limitation. Since it's a proposition, it is either true or false, but we don't know if it's true or it's false. So now let's determine validity. Our premise we assume is true. Our conclusion could be true, but it could also be false. So is it possible here to have a true premise and a false conclusion? That's certainly one possibility. It's either going to be TT or it's going to be TF. One of those possibilities, well, that's not valid. So our final answer, this one is invalid. Let's go on to our third example for this video. And if you can't quite read, again, follow along on the text. I know the print is small, but maybe you can blow up that YouTube screen here. So all dry martinis are dangerous concoctions. We don't care about martinis so much. All SRP. All SRP, that's an A. And then our conclusion, it's negated. It is false that, but I'm going to set that aside. I just want to identify the letter name. It is false that some S are not P. Some S are not P, that's an O proposition. So let's note the relationship between the two. A to O. These are contradictory. So the A, we assume that our premise is true. They must have opposite truth values. So O itself has to be false. But remember that this one is negated. So since it's negated, our F becomes a T. And that would give us a true premise and a true conclusion. That would be our final answer. We assume that the A is true. A to O, those are contradictory. So the O would be false, but remember this one's negated. It is false that. So that would give us a conclusion that is in fact true. So TT, that would be valid. Two more examples. The premise here, again, in our second to last example, it's negated. I'm going to ignore that. I'm going to start just by identifying the letter name. It's false that, set that aside. No credit cards or things that contain holograms. And strip the content, we have no SRP, no SRRP, that's an E proposition. And then the conclusion, some credit cards or things that contain holograms. Strip the content, identify the letter name from earlier in chapter 4. We have some SRP. Some SRP, that's an I. So we're going from E to I. E to I, note the relationship, they're contradictory. Our premise is negated. So the E itself has to be false, but in testing for validity, we assume that the premise is true. E itself is false. So let's start right there. E is false. We're transitioning from E to I. The relationship between E and I, according to the modern square, is contradictory, meaning they must have opposite truth values. So EI, if E we're told is false, then I must be true. So the premise we assume is true. I we concluded according to the modern square is true. So this gives us TT, which is in fact valid. And let's take a look at one more example. Pay no attention to the following papers there. One last example. It's false that. I'm going to set that aside. I'm going to instead I'm going to start by identifying the letter name. All SRP. I don't even bother with the content. Let's just cut to the chase here. This is all about the syntax and not the semantics. All SRP, that's an A. Some S are not P. Some S are not P. Back to my cheat sheet here at the top. That's an O. The relationship between A and O, I'll make note this time, they're contradictory. Our premise is negated. Our premise is negated. So A, that means, is false. The relationship between the two, they're contradictory. So they must have, again, opposite values. If A is false, then O is true. A itself is false, but we assume that our premise is true. So that gives us T, therefore T, and that, again, would be a valid inference. So continue to practice. Obviously, check your answers. If you're consistently getting them correct, you should be well prepared for the test. If you're making mistakes, rewatch the videos, of course, but don't hesitate to contact me. My office is G154, first floor of Glen Anthon. More than happy to meet with you. It was kind of odd taking an online class where you don't necessarily see your instructor on a regular basis, but I hold daily office hours. Feel free to stop by at any point. Or, for that matter, send me an email, and I always try, including on weekends, to respond within 24 hours. I'm here to help, so if you're making mistakes, let's get those corrected before you take a test.